Now I'm going to cover chapter 7.6 or section 7.6 and 7.7 in one video here. Now this 7.6 is perhaps one of the hardest sections in the book, and it's one of the places where people get stuck the most, but there's not much to say about it because the only information, the only advice I have for you is the same advice that we've had in previous videos. If we're solving trig identities, look at the thing that you've got, start with the most complicated, fiddliest looking side, simplify it until you get the other side. So in this case, I'd probably start on the left hand side and try and simplify it into the right hand side. Think of all the tricks that you know with trig. Think of all the tricks that you know with algebra. Can you factorize? Can you use a difference of two squares? Is there a fraction that something might cancel out on the top and the bottom? Can you collect like terms? All of those sorts of things. They're the algebraic tricks. Then think, okay, can I use sine and cos and combine them? You know, sine over cos equals tan. Can I use sine squared plus cos squared equals 1? Can I convert coses into sine with 1 minus sine squared equals cos squared, or 1 minus cos squared equals sine squared? Are there sec, tan, or cosec knocking around, and can we use those identities? You know, we know that tan squared and sec squared are linked with an identity. Cosec squared and cot squared are linked with an identity. Then we've got our double angle formulas, our half angle formulas, and our a plus b, sine and cos and tan of a plus b formulas. So double angle formulas, if you have a sine times a cos, then you're thinking that that is sine of double the angle. If you have a cos squared minus sine squared, or a cos squared or a sine squared on their own, you're thinking of that as cos of double the angle. And if you have some sort of hideous mess that looks a bit like the right hand side of the tan 2 theta formula, then can you use that? Okay, so you're looking at all of those things and sort of seeing what you can do. Now that advice in outline is advice that I've given in lots of other videos leading up to this. I suppose the other bit of advice, which is kind of new, is make sure you know all the stages up to here. So if you're getting stuck on this stage of this chapter, first question to ask yourself is, can you do all of the trigonometry up to here? Okay, this is quite a nasty bit. And the reason it's difficult is that it needs all the other information really embedded and the latest information that we've got as well. So if you're not happy with the stuff from the previous chapters, go back and practice. It's all covered in other videos on this playlist or on the year 1 Pure Book playlist. Follow the same advice. Okay, now I'll come back and do a couple of examples in a minute because if I don't, then somebody always gets annoyed. So I'll come back and do those examples, but really that is the information, that's the advice. Modelling with trig functions, there isn't much to say there. Again, not that they're easy questions, but there isn't anything new to add, right? These trig functions are, you know, the modelling sections rather, are where they take the information you've got and put it into some sort of context. I can't really give you advice on every possible context. You're just going to have to read the question, think of all the information you know, and hopefully apply the right ideas. And we're used to that now. The exam board like to talk more about modelling than they used to, so they provide sections within the chapters where they give you lots of applied questions. There's no new maths there, just hard questions to think about. So there's nothing I can give you really in a sort of tutorial video. So that's all the advice. Let's just go back and think our way through these examples. So looking at this one, as I said, I'd start with the left hand side, and I've got sines and coses, and I want to go for sines. I've also got sine times cos, and the input to the sine here and the input to the cos here are the same thing. So I'll be looking at that thinking sine of 2 theta. Now I've also got sine of 2 theta over the right hand side, so there's an extra hint for me, right? Sorry, I'm thinking sine of double this thing. So I'm thinking sine of theta, so sine cos can be turned into sine of theta. And the fact that I've got a 2 theta over here and only thetas and theta over 2's here means that probably I'm going to use some sort of double angle formula, right? So, well, 2 sine theta cos theta is going to be one lot of sine theta. And then, well, that's actually the whole thing done, isn't it? Because then I'll have a sine times a cos, and the sine times a cos, I'm using my double angle formula. But sine of 2 theta is 2 sine cos, and I've only got one lot of sine cos, so we end up with a half of sine 2 theta. Now with this one, I can't think of anything else clever to do, right? There isn't anything there's no sort of factorising of things, there's no cancelling out of fractions, so I'm immediately drawn into the sine times the cos. Now if you don't see that straight away, that's fine, that's because you've not had the same sort of experience of looking at these and spotting those sorts of things. So next time when you see a sine times a cos, try a sine double angle formula. Now this one here, I'm desperately trying to avoid looking in the blue box so that I'm not being biased here, but I'm actually looking at this thinking, well, this looks a bit fiddly. I wouldn't say the left hand side or the right hand side is simpler. I'll probably start with the left hand side. I'm noticing that I've got a cos 2 theta here and I've got a 4 theta on the left hand side. So that gives me the hint that I'm going to use the double angle formula, or the half angle formula if you prefer to call it that, and apply it to here. And I'm going to use the one that has a cos squared in it, not the cos squared minus sine squared. So if I apply that to here and write cos 4 theta in terms of cos 2 theta, then I'm hoping that the ones will cancel out nicely and I'll end up with what I've got here. And now I look lower down and that indeed is what's happened. Look. So cos 4 theta is 2 cos squared, 2 theta take away 1. The ones cancel out and then I get what I wanted. So it's that technique. Look at what you've got. Look, and after a bit of experience, you start to notice the things that, okay, there's a 2 theta here, there's a 4 theta here, so double angle formulas. There's a sine times a cos, so double angle formula. And of course, by the time you get to the exercise and by the time you get to the exam, there's nothing saying you're definitely going to be using double angle formulae. You could be using anything from anywhere in the book. Let's just have a look at this one. Again, I'm not looking in the blue box deliberately. And I'm looking at this and I'm thinking, okay, the right hand side is more complicated than the left hand side. I know that I've got an expression for tan 2 theta, so maybe I can turn the right hand side to something that looks familiar. I'm also looking at the bottom and thinking, well, I've got a cot and a tan, so maybe if I turn everything into tans. So I think my instinct here will be to do 1 over cot on the bottom, then to simplify the bottom with algebraic fractions. I'm going to have a fraction on the bottom, so I'll be able to flip that upside down and make something on the top, and hopefully by that point it will have simplified to what I want. And there we go. Oh, it's not the way they've done it here. Divide the numerator and denominator by tan theta. Well, that's the way they've chosen to do it. Should we see if my version would have worked? And if it doesn't, then that's just an illustration of how easy it is to not know what to do. I would have gone for this, and I would have written that as 1 minus tan squared over tan theta. That's 2 divided by this fraction on the bottom, so that's 2 tan theta over 1 minus tan squared theta. So there you go. My way of thinking about it does work as well. That is the expression for tan 2 theta. Okay. This one here, we have to spot that this is the technique from section 7.5. So it's something times cos plus something times sine. Well, the something times sine is just 1 times sine. But if we realise that that can be written in this form, then we could use the r sine theta plus alpha form. That's the way I do this. And now I look in the blue box and find again that they've done it a different way. They've taken the right hand side and expanded that out and turned it into the left hand side. So either way, we could take that and apply the technique from section 7.5, or we could take this and apply the a plus b formula to it, and it'll simplify down. Okay, so there's actually quite interesting looking at those 3 examples. 2 of them I thought of in a different way to the way the book thought of them. There we go, section 7.6 and 7.7, and in fact chapter 7 all finished.